Good day and welcome to another episode of my reviewer series for civil engineering topics focusing on geotechnical engineering problems. For this episode, a 0.3 meter square pre-stressed concrete pile is to be driven in a clay soil as shown in the figure. We are instructed to use alpha method with a factor of safety of 2 in determining the following: the end bearing capacity of the pile if NC equals 9, the skin friction expected to develop along the shaft, and the total design capacity of the pile. When it comes to static pile analysis, there are only two forces that we need to consider. One is our end bearing resistance, or yung vertical reaction force dun sa tip ng pile once it is driven. And the other one is our skin friction resistance, or yung friction force experienced along sa body ng pile natin. And take note, iba-iba ang analysis ng mga forces na to depending on the type of soil na present sa situation. For this case, ang material present is clay soil. And actually, meron akong personal trick para madaling maalala yung formula para sa ganitong problems involving clay. So the phrase, piles on clay can clap, constitutes mnemonics that might be useful for some of you, especially sa mga nagpa-plan na mag-memorize ng formulas for their tests or sa board exams. Sabi nga nila, ang talagang labanan ng subject na HGE sa boards is paramihan ng mamememorize na formulas. So better, kung ngayon ay student ka pa lang, tas nagkataon pa na napanood mo tong discussion na to, edi at least may isa ka ng formula na madali mo talagang matatandaan. So looking at how we can use this phrase, our end bearing resistance is equal to the mnemonic can, and our skin friction resistance is equal to our mnemonic clap. Just to elaborate our formulas, C stands for the cohesion, A stands for the area of the pile tip, and N, or as given in our problem as NC, is actually our bearing capacity factor due to cohesion. L from clap naman stands for the length submerged or driven in the soil layer. Yung alpha natin is the factor used for this method, and P stands for the perimeter of the cross-sectional area of the pile. Adding the two resisting forces, we can actually get the ultimate bearing load of our concrete pile. And technically speaking, we already have our formulas to solve for 1 and 2. So to make this more convenient, kunin na rin natin formula ni number 3. Take note, kasi isa to sa mga usually na napagkakapalit ng ibang students, the difference between design capacity and our ultimate capacity is that si design ay ang allowable strength or yung reduced capacity for a safer usage. While si ultimate naman ay yung peak strength kung saan approaching limit na yung capacity pero tolerable pa rin niya yung resisting force. So basically, basta hindi pa factored yung value, automatic siya yung ultimate capacity natin. So in order to solve for our design capacity, ang gagawin lang is di-divide natin ito sa given na factor of safety. Since kompleto na yung mga need natin na formulas, balikan natin yung mga given sa figure para plug na lang natin yung values sa mga equation. Madali lang talaga ito since single file lang yung given sa problem. Pero para malaman nyo naman kung paano naman yung analysis ng load file as a group, baka i-release ko na rin dito isa sa mga problems soon. Pero anyways, solving for question 1, ang i-consider lang natin na cohesion value is yun dun sa layer na kung saan nag-rest yung pile tip, which is dun sa stiff clay soil. So RC is equal to 96 kPa, and our pile tip area as given is 0.3 by 0.3 square meters. And our bearing capacity factor naman due to cohesion is NC equal to 9. That gives us an end bearing capacity of 77.76 kilonewtons. Para naman sa skin friction, dito need natin i-consider yung variations ng soil na dadaanan nito. To do that, summation ng different values plugged in sa formula ang need natin i-perform. To understand what I mean, mag-plug in tayo ng values. Since dalawang layer type ng soil clay yung meron sa figure natin, unahin muna natin yung sa taas. Ang cohesion ng soft clay natin is C equal to 28 kPa. Length equal to 6 meters, alpha factor is 1, and perimeter natin is 0.3 times 4. Since ipag-a-add lang natin is sides ng square. Then, adding the skin friction of the layer below, 96 yung cohesion value, 8 meters yung length na tinagusan ng pile, 0.5 yung alpha factor na given, and same perimeter lang din siya all throughout, kaya 0.3 times 4 ulit. Solving this gives us a skin friction value of 662.4 kilonewtons. Since nakuha na natin both end bearing and skin friction resistance, add na lang natin both para makuha yung ultimate bearing capacity. And given na yung factor of safety natin is a value of 2, divide na lang natin si ultimate capacity by this value, then makukuha na natin yung answer for number 3, which is a design capacity of 370.08 kilonewtons. So, ganun lang siya kabilis. That concludes this episode's situation.